One shared LLM queue can make indexing, evaluation, and audit block each other under load. You'll publish one LLM event to NATS JetStream and fan it out to independent durable pull consumers with explicit acknowledgements. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. A completed LLM response often needs several follow-up jobs. You may index it for search, evaluate its quality, and write an audit record. If one worker is slow, a shared queue can turn that one delay into a delay for everything else. NATS JetStream fits this job because it stores events durably while letting different workers track their own progress. You do not need custom handoffs between every service. The producer sends one compact event, and each workflow decides when it has truly finished. A response event should not disappear just because an evaluator is busy. We want one retained record, separate delivery tracking, and safe retries when a worker fails halfway through its task. We will create a small event stream, publish LLM metadata, attach 3 independent workers, and watch each one receive the same event. The important new idea is a durable consumer. It remembers where one worker is in the stream, even when other workers move at a different speed. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We first need a durable place for events to land. This snippet connects to local NATS JetStream and creates the LLM event stream for LLM.events. A shared stream removes brittle worker handoffs because producers target one subject while JetStream retains events for downstream processing. The connection object stays available for later steps, so we can keep using the same server session. When add stream returns, info.config.name confirms that the server created the stream configuration. The visible stream value is LLM events, establishing the durable event log that indexing, evaluation, and audit will share. Keeping this setup small also preserves a short publishing path for latency-sensitive LLM applications. Now that the stream can retain events, the producer needs to send one useful record instead of contacting every downstream service. This example publishes one structured LLM event to NATS JetStream through js.publish. The event carries an identifier, type, and token count, representing compact metadata attached to a completed model response. JSON dumps turns that structured data into predictable bytes for transport. The NATS MSID header gives JetStream a publication identity, so it can recognize a repeated send within its configured duplicate window. The producer still makes one publish operation rather than calling indexing, evaluation, and audit services separately. The printed published ID and stream secu show which event JetStream accepted and where it stored that event in the stream. One stored event is not fan-out yet. Each workflow needs its own remembered position, so one slow worker cannot hold the others back. This code creates independent NATS JetStream durable consumers for indexing, evaluation, and audit. Each pull subscribe call attaches separate delivery state to the same stream, so a delayed evaluation worker does not hold back indexing or audit. Consumer config selects accPolicy.explicit, which means JetStream waits for a worker to report real completion instead of treating delivery as success. The short ACK wait makes retries easy to observe. Increasing it gives slow model evaluations more time, while decreasing it retries sooner but can create concurrent redeliveries. The output confirms that all 3 durable worker identities now exist and are ready to track work independently. For more practical lessons on Python, data systems, and AI engineering, please subscribe. Those workers now have separate state. So the next question is whether each one actually receives the same published event. This snippet pulls the same event through every NATS JetStream durable consumer and explicitly acknowledges each delivery. Each sub owns an independent cursor, so fetch returns EVT1 for index, eval, and audit, even though the producer published it only once. JSON.loads recovers the application event identifier from the message payload. Then MSG-ACK records completion only after that worker has handled its payload. The loop is sequential for screen clarity, but the durable states remain independent and can run in separate processes at different rates. The fan-out output proves that every workflow received its own tracked delivery without forcing the producer to repeat the event. An acknowledgement can still be lost after a worker finishes its task, so the handler must safely face a redelivery. This example demonstrates a safe NATS JetStream retry when processing finishes, but the first acknowledgement never arrives. The eval consumer records EVT2 in seam, waits beyond ACK wait, and receives the unacknowledged event again through fetch. Checking event ID before repeating the side effect makes the handler idempotent, meaning a repeated delivery does not repeat costly work. Then MSG.ACK completes the retried delivery, and NC.close ends the demo cleanly. Seam is intentionally in memory here. Production workers normally use a persistent idempotency record that survives restarts. The output shows one unique write and one skipped retry, preventing redelivery from duplicating expensive evaluation work. When evaluation writes to a database or calls a paid model API, keep the idempotency record close to that side effect. An in-memory set is useful for learning, but it disappears on restart. A database row with a unique event identifier or a durable key value record gives the worker a stable memory of work that already happened. This pattern is different from a plain work queue. A work queue usually distributes one job to one available worker. That is great when many workers share the same task, such as processing a backlog of documents. Fan-out is better when several independent teams need every LLM event, such as retrieval indexing, quality evaluation, billing, and compliance. The producer stays simple. Git publishes once. JetStream stores the event. Each durable consumer advances only after its own acknowledgement. That separation is what prevents an overloaded evaluator from blocking a fast indexer. Try changing ACK wait and observe the trade-off. A longer value reduces early retries for slow work. A shorter value detects missing acknowledgements sooner, but makes idempotent processing even more important. What practical LLM systems topic would you like to explore next? From event design to reliable evaluation pipelines. Share it in the comments, and subscribe if you want more clear Python and AI engineering lessons.